This video is the product rule and the quotient rule. So this is just some more derivative rules if you come across a problem that's being multiplied or divided. Again, if it's multiplied, you can just go ahead and do the multiplying and then use the power rule like this. So if you remember, we have to say this times both, and then this times both, and then combine it all together. So we get y equals, and I'm not taking the derivative yet, I'm just simplifying the problem, plus 2x to the third, x times 2x is 2x to the third, x times 3x is 3x squared, negative 14x squared, negative 21x. Now, well, I can put these together. So 2x cubed minus 11x squared minus 21x. Now I can take the derivative. So 6x squared minus 22x minus 21. So that's one way of doing it. However, multiplying can become much messier than that, and you may not want to multiply first. So this is another rule that you can use to take the derivative when two things are being multiplied. And so what it is you take u of x and times it by the derivative of v of x. All that means is you take the first and times it by the derivative of the second. And then you add and you take the second and times it by the derivative of the first. So kind of like the distributive, just a bigger thing. Okay, so y prime is going to equal the first times the derivative of this. So, 4x to the first plus 3. And then we add, and then we take the second, just as it is, and multiply it times the derivative of the first, which is just 1. And then multiply it out and combine it all together. So y prime equals this. Okay, find the derivative of the following function using the product rule. Okay, so here again you can multiply it out and use the power rule, or use the product rule. So the first, so f prime of x, the first times the derivative of the second plus the second times the derivative of the first. Okay, so at this point you can stop unless it tells you to simplify. If it tells you to simplify, then you're going to have to go ahead and do the rest of it. I'm pretty sure on the homework it wants you to simplify. So I'm going to pause this, simplify it, and then you can come and look at what I've done if you choose. Okay, so that's it simplified. If you need help or have questions, just ask. And moving along. It says use the product rule to find the derivative, but do not simplify your answer. Okay, so first thing that you want to do is change, wrong tab. Is change, rewrite your functions. So x to the 1/5 minus 2x to the 1/4 plus 1, and this one's okay. Alright, so x to the first one stays the same, and times by the derivative of the second. It's 3 times 1 is 3, minus 1 is 2, and then x plus the second times the derivative of the first, which would be 1/5 x. 1/5 minus 5/5 would be negative 4/5 minus 2 times 1/4 is 1/2 x. 1/4 minus 4/4, remember always use that bottom number, negative 3/4, and then plus 1 would be 0, and so that's the derivative of that, of the beginning. And it said do not simplify, because that would be very messy to try and multiply all that and then add it all together. Okay, so it says find the derivative. Do not simplify. Since it's a product, we can use the product rule. I don't really wish to multiply that out to do the other rule. So I'm going to do the first times the derivative of the second plus the second times the derivative of the first. Okay, now since this is the derivative, we can simply put 2 in there just like it is. We don't have to simplify it. But remember, the slope of the tangent line is when the derivative of that x value is the derivative of that x value. So if we plug this into all of that, you should get 315. And then it says find the instantaneous rate of change. Well, we plug the 2 in, so we're going to get the same thing. So that also equals 315. Write the equation of the line, the tangent line, at x equals 2. So we need that slope, which was 315. And then we need the value of at the function of x, not the derivative. So we need 2, and we plug 2 into the original equation. And then we would get 63. And then to find the equation, y minus the y value, the slope times x minus the x value. And then add 6. And we get y equals 315x minus 620. 63. And that gives us 567. Shh, it's okay. It's okay. Sorry. I'm going to pause this. You're going to hear my dog. Nope. Okay. And then I think that's the end of that problem. Shh, it's okay. It's okay. Okay, the quotient rule. And now the quotient rule. So the quotient rule is just if you have two polynomials and you're going to be dividing. And of course, the bottom can't be 0. If you notice, this is just exactly like the multiplying, except it's a subtract instead of multiply. And then we have this bottom. So the quotient rule to do this one. So y prime is equal to, okay, ux, except our polynomials, one's on top and one's on bottom. So the first one, we leave it alone. My bad. You do the ux and vx. So let's name the top ux and let's name the bottom v of x. Those look the same. U of x and the bottom is going to be v of x. So this one says the bottom, the v of x times the derivative of the first, the top. And then the top times the derivative of the bottom. So if you want to write that here, you can say bottom, top, top, bottom. Okay, so the bottom we leave alone, and then we do the derivative of the top. So 6x squared, no, 6x to the first, it's got to subtract 1, plus 9, minus. Now, all of this has to go together, so that's why I'm going to put this bracket here. So the top, 3x squared plus 9x minus 4 times the derivative of the bottom. Okay, and since that's a 1, 1 times 1, 1 minus 1 is 0, that's why we just have 1. Now the reason I put this bracket is because once you multiply, then the subtraction has to go to everything. This subtraction is simply just a simple one. And then on the bottom, is this squared. So let's clean the top up. This is going to become 6x squared minus 12x plus 9x minus 18. This is all just 1, so minus 3x2 minus 9x plus 4. And that gives us 3x squared negative 12x minus 12x minus 18 plus 4 is minus 14 over x minus 2 squared. And you could multiply that out or leave it. So if we multiplied it out, it would be 3x squared minus 12x minus 14 over x squared minus 4x plus 4. So this would be the derivative. Alright, same thing. So we're going to call this u of x, this v of x. So y1 is the bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. And so that would be, you could stop there, or if it says to simplify, you can go on and simplify. I'm going to pause it, and so it'll just show up in just a second. So there is the algebra on the top. I didn't do the bottom. This should be an 8. I made that mistake, which makes this a negative 29. If you have any questions, just ask. The last couple are application problems. And it's really just doing what we've been doing. The sale of a product S in thousands of dollars are related to advertising expenses in thousands of dollars by this function. Find the rate of change of sales with respect to advertising expenses when x equals 10. Well, we learned that the rate of change was the same as the derivative of the function. So we have the derivative of the function of the quotient. So that was the bottom times the derivative of the top minus the top, I'm going to put it in brackets, times the derivative of the bottom over the bottom squared. Okay, so on top we have 200x plus 2000 minus 200x, and on the bottom we have x plus 10 squared. So that gives us 2000 over x plus 10 squared. So now if we put 10 in, we get 2000 over 100. And so the rate of change with respect to 10 would be, that's 400, silly, which would be 5. So we can say the sales will increase by about 5. Remember, we're talking $1,000 if the advertising expenses change from 10 to $11,000. Okay. Next, it says McRoberts Electronics sells 200 TVs per month at a price of $400 per unit. Market research indicates that the store can sell one additional TV for each dollar it reduces the price. In this case, the total revenue is this, where X is the number of additional TVs beyond the 200. If the store sells 250 TVs, find the marginal revenue. Interpret your result. Okay, so here's our function. And the marginal revenue is the same as the first derivative. So we're going to take the first derivative. If we remember, that's the first one times the derivative of the second, which would be -1, plus, because it's a product, the second one times the derivative of the first one. So we've got 200 plus -x plus 400 minus x, which gives us -2x plus 200. So the derivative is this, and then x would be 50 because it says TVs beyond 200, and so we plug that in and do r of 50, r prime of 50, and we get 100. So we can say that we expect the revenue to increase by about $100 when the 251st TV is sold. And that's all in 9.5.